So as somebody said that SSL is secure socket layer. So it provides the security of all the messages that are transmitted from the client machine to the server and vice versa. Okay. Now SSL has got a similar equivalent security mechanism, which is called as the TLS, transport layer security. There are some differences between SSL and TLS. SSL was developed by Netscape. There is a Netscape Corporation is a very big company in those days, which was developing the browser. We know very well that earlier we had only Microsoft Internet Explorer and Netscape Navigator. Okay. Nowadays we are having plenty of browsers. Okay. So in order to interact with the web server, we need a web browser. And what is a web browser? A web browser is a client program that is used to access the resources of internet. What are the resources of internet? There are plenty of resources of internet. Web is a resource. FTP, email, search engine. There are several kinds of things that can be done in the internet. So therefore, in order to access these resources, we need the web browser. Okay. So Netscape was a company which developed the concept of SSL, secure socket layer. Okay. SSL is a pipe between the browser and the server. What is a web server? A web server is a machine or a system that provides the service to the clients. Whoever is accessed some information, received a request, those will be served by the web server. Okay, so for a web, we need both web browser and web server, whereas SSL provides security in between these two things, web browser and the web server. Okay, if you look at the architecture, that is the logical design of SSL, how it is designed. We have got the SSL, which is working in between the application layer and the TCP layer. Okay, so SSL is functioning between that. So there are certain protocols like SSL record protocol, SSL handshake protocol, SSL chain cipherspec protocol, and alert protocol. These are the 4 important things as far as SSL is concerned, that is securing the messages or securing the web is concerned. Okay, so how does it work? Now, these are also under the layering concept. Layering means what? You know, in TCP/IP there are several layers. Okay, the physical layer, the data link layer, then the internet layer, the TCP layer or transport layer, and the application layer. Okay, so layer means a layer will perform a unique set of functions. That is why we are having this layering concept in our internet, or in network also we have got that. Now, it is a 2-layer protocol. Layer 1 consists of the SSL record protocol. See, this you can see above the TCP, you can see the SSL record protocol. And the second layer is the layer 2, which is in turn divided into 3 things: handshake protocol, chain cipherspec protocol, and alert protocol. So there are 2 important layers in your SSL. In order to make all the web transactions more secure, we've got 2 layers. Layer 1, that is SSL record protocol. Layer 2 has got 3 protocols, that is handshake protocol, chain cipherspec protocol, and alert protocol. So what does this SSL record protocol do? 2 important services. One is the confidentiality, the other one is the message integrity. What do you mean by confidentiality? Everyone knows that you are achieving this confidentiality so that the message which is transmitted from one machine reaches the other, or the receiver or the recipient. Only he who is sending and the one who is receiving will know what is the kind of message. Nobody else should know. Achieving that is known as confidentiality. And how do you achieve that? We are having the cryptography algorithms in order to achieve that confidentiality. Okay, so therefore by encrypting and decrypting we are achieving this service, that is confidentiality. It is one important service of the record protocol. The other service is the message integrity. By using the MAC code, message authentication code, by computing the MAC code on the original message, we are able to achieve the integrity of the messages that are transmitted in the internet. Okay, so the SSL protocol, record protocol, does certain things. Okay, how does it distinguish the TCP packet with the SSL packet? Means what it will do is it will add its own header, that is called as the SSL record header. You can see the last in the diagram, we have done that. Then it will encrypt the will come from this way. The application data. The application data may be any kind of web application data that will be divided into fragments of equal size blocks. Suppose one fragment does not have the size of the data, means we will go for padding. Okay, so that is the first step. The first step is you take the application data, and second step is you fragment the application data into equal sized blocks, and then you compress using the compression algorithm, which we have seen in the PGP and all. What is the meaning for the compression algorithm? Then in order to achieve the integrity, we add the MAC. MAC is added to achieve integrity and encrypt the message, whatever is done before. That is, after adding the MAC, you are encrypting the message and appending the SSL record header. So the SSL record header will contain what is the type of encryption done, what is the value of MAC, and these kind of details will be present in the SSL record header. This is the size of the packet that is transmitted in the internet and which is more secure. Okay, so this is what I said. The next three layer 2 protocols are what? Handshake protocol, then chain cipher spec protocol, and the alert protocol. Okay, so the handshake protocol works as follows. There is a link, there should be a connection establishment between the client and the server. Client gives the security capabilities, what is the protocol version, session ID, etc., to the server by the message client hello. The server receives that and sends back the message to the client saying server hello, means there is a connection established between the client and server. This is the first step of the handshake protocol. Then after that, what happens is the server will give the details, certain details to the client in order to ensure the security. What are the details are? It will issue the certificate, the key exchange, the certificate request, the server hello done. What is the certificate? It may be X500 series, any one certificate under the X500 series, probably X509 digital certificate, and all these things are given to the client. This is the second phase of the handshake protocol. The first phase is client hello, server hello, and the second phase is issuing the server issuing the or giving the certificate, key exchange, certificate request, and server hello done. Okay, then after that, if the time is prolonged, client is not replying, means what happens? There is a disconnection. There may be a disconnection. So what happens here afterward? You will not send the handshake protocol, will discontinue. So if it is not like that, this client will send the service, the certificate requested by the server and key exchange and the certificate verification to the server, means he is there in the online or he is there live. Okay, this is the third phase of the handshake protocol. The fourth phase only, the change cipher spec comes. That is to finish the exchange of messages between the client and server. It is indicated in the change cipher spec. So by enabling the bit or byte in the change cipher spec, we come to a conclusion that the protocol, handshake protocol, has come to an end. Okay, so this is how the handshake protocol functions in the SSL for providing security. Okay, so coming to the chain cipher spec protocol, it consists of a single byte with a value 1. If the value is 0, what happens is it means that there is something something which is not pending. Okay, the purpose of this message is to note the state of the handshake protocol, state of the connection. Okay, so mainly for the chain cipher protocol functions as a coordination protocol, coordinates between the client and server. Okay, so the client must send it to the server and server must send it to the client. Chain cipher spec should be changed by the client and the server. That is most important. Okay, then alert protocol. The alert protocol conveys certain SSL related alerts. So for example, if the value is 1 means warning. If it contains 2 means it is fatal. Fatal means what? There is a severe problem for the message and that connection will be terminated. So these are byte values. The byte value of 1 indicates in the alert protocol, if the byte value of 1 indicates, see here in this diagram, if the byte value of 1 indicates it is warning, and if it is 2 means what happens, it is fatal. There is a termination of connection. Okay, so this is how the SSL protocol or SSL security functions in your internet in order to provide web security.